Hey everyone, today we're going to be learning how to integrate. So integration is actually very simple and I'm going to show you how to do it very easily. So the first thing that you need to know is the general formula for integrating. So if we have the integral of we have to integrate x to the power of n, right? First things first, this is the integral sign. This is what we're integrating, and this dx essentially acts as a bracket. It closes off what we're integrating. So if we have this, then very simply it's just going to be x to the power of n plus 1 over n plus 1 plus c. Okay, now I'm going to explain what this c actually means. First things first, it's important to know integration is the opposite of differentiation, and differentiation is the opposite of integration, right? So if we have a value, look, let's actually go ahead and do it. So first things first is we're going to do some integration. So let's say we have the problem. We have to integrate 4x to the 5 dx. Okay, what are we going to do? Well, what we have is the constant multiple rule. So what we can do, we can bring out the coefficient here. Then we can make it 4 times the integral of x to the 5 dx. Okay, and that then is going to equal what? Well, it's going to be 4 times x to the power of 5. So we're going to add 1 to that 5. So it's going to be x to the power of 6. And then n plus 1. So it's going to be over 6. And then that is going to equal, so 3 times 2, 2 times 2. So it's going to be 2x to the power of 6 over 3 plus c, right? Always remember that plus c. Now, let's quickly remember the formula, right? The constant multiple rule. So it basically states that if we have to integrate a function that's like k times f of x, then what we can do, right, with where this is a coefficient, as we saw, the 4, we can bring that k out and just integrate the function itself. So then it's going to be equal to k times the integral of f of x dx. Now, I'm going to go ahead and I'm going to have an equation. I'm going to differentiate it. Then I'm going to integrate it to get back to the original equation to show you how integration and differentiation are basically the opposite sort of calculations. So let's say we have an equation y is equal to, I don't know, let's say 3x to the power of 8 plus 9x to the power of 3 plus 27x squared. Okay, the question's asking us, let's differentiate. So dy dx over dx is going to be equal to, right? If you need to watch the previous video on differentiation to understand how to differentiate. But what we do is we take the power, we bring it and we multiply this little value by that power, and then we reduce the power by 1. So it's going to be 8 times 3x, and then 8 is reduced by 1, so we subtract 1. So it's going to be 7 plus 3 times 9x, 3 minus 1 is 2, plus 27 times, oh, my bad here, okay, plus 2, right? We bring that 2 into the front here, so plus 2 times 27x. Okay, and now we're going to get 24x to the power of 7 plus 27x squared plus 54x. Okay, so now we found the first derivative of this equation here. Now, as I said at the start of the video, integration is the opposite of differentiation. So if that's true, then if we go ahead and we integrate this, which is the first derivative, then we should get back to this original equation. So let's go ahead and see if that's actually true. So we have we want to integrate 24x to the power of 7 plus 27x squared plus 54x dx, right? I'm going to use the constant multiple rule, right? So it's going to be 24 times the integral of x to the power of 7 dx plus 27 times the integral of x squared dx plus 54 times the integral of x dx. Okay, now what's going to happen is I'm going to go ahead and integrate these. So we use this formula here. So it's simply going to be 24 times x to the power of 7 plus 1 is simply going to be x to the power of 8 over n plus 1. So n is 7, so 7 plus 1 is 8. Good. Plus 27 times x to the power of 2 plus 1 is going to be x to the power of 3. And then, right, the n is 2 in this scenario. So 2 plus 1 is going to be 3. Plus 54 times x to the power of 2 over 2 plus our constant multiplier of c. Now I'm going to explain why we have that, why we have the integration coefficient in a following section on this video. So we're going to simply simplify this down. So 24 times 1 over, well, x to the power of 8 over 8. That's just going to leave 3x to the power of 8. Then we're going to have here 9 plus 9x cubed. Then this here is going to be 27. So it's going to be 27x squared plus c, right? These are indefinite integrals. Okay, so if we now look and we compare what we've integrated to our original equation, we can see they match, right? So integration is the opposite of differentiation. Now, what about the c? Okay, right, so this c represents the constant of integration. So we've done this question. I'm going to go ahead and show you another question, all right? Let's say we have y is equal to 3x plus 4, okay? And we go ahead and we find the first derivative. That's just simply going to be 3. Now, if we want to integrate this value here, what we go ahead and do is we do just that. So it's going to be the integral of 3 dx, and that is simply going to be 3x, right? If we don't add the constant of integration, this here is incorrect, right? So we have to add that constant of integration in order to get back to that original equation, right? Because this 4, it could be absolutely anything, because when we do that differentiation, when we find the first derivative, we lose that constant. The constant could be 100, it could be 1,000, it could be negative 100, it could be any value. But when we do the first derivative, we lose it, right? Because it's got here 4x to the power of 0. And so then if we differentiate it, then it comes down 0, and we lose 0 times anything is just going to be 0. So we lose that constant. And so therefore, whenever we integrate something, we have to add that constant of integration in order to basically acknowledge that there is a potential value here, right? If this was 0, right, if it was just y is equal to 3x, and our first derivative is 3, then this here, when we integrate just 3, that plus c would represent 0. So that constant of integration is really important in order to basically acknowledge how differentiation works, right? So always remember that constant of integration. Always remember to put it there, okay? That's really, really important. You can actually lose marks for not including the constant of integration. Because if you left here just 3x, right? If we had only 3x, let's say we had only 3x, would our answer be correct? Well, no, because there was that 4. But when we're just integrating, we don't actually know if that 4 is there. We don't know if it's a 4, we don't know if it's a 5, we don't know if it's 100,000, right? So by putting that plus c, that constant of integration, we acknowledge that there may potentially be a constant in the original equation. So that's it for this video. I hope you found it helpful. If you did, check out some of the other content on my channel, and I hope you have a good day. Bye-bye.